All right. Hello, my name is Rama Mwenesi, and I'm a second-year master's student in the Healthcare Engineering and Patient Safety program at the University of Michigan. Over the past year, I've been fortunate enough to work on a very interesting and exciting research project, which ultimately involves improving innovations in surgical instrument reprocessing at the University of Michigan Health System. So, in collaboration with clinicians and staff at the university hospital, we came to realize that there was a significant problem in terms of instrument sets arriving into the operating rooms as either having dirty or dysfunctional instruments within them. We took the opportunity to look at the data, and what we realized was that there were significant sets which were the key issues or key problem makers. Taking that a step further, we sought to identify what instruments within each of those sets were attributing these causes, these issues. We then asked ourselves, what was it about those instruments in particular that caused the entire instrument set to be sent back? Because, if I may point out here, taking a look at the minor neuro instrument set in particular, that instrument set has 123 items inside it, whereas if one instrument showed up as having bioburden, or what we call dirt from a previous patient, if one instrument showed up as having bioburden on it, the entire tray of 123 instruments would have to be sent back for reprocessing. As such, you can imagine the implications on all the institutional outcome measures. And so, going back to our solution and our approach, we sought to identify what aspects made instruments harder to clean than others. Our hypothesis was that instrument design features impact instrument cleanability. And so what we were able to do was create a cleanability index that essentially allows clinicians and staff and general lay people alike to assess how cleanable, how hard or easy an instrument is to clean on a 1 to 5 scale, for example. That prompted us to ask the next question. What happens if we sequester the harder to clean instruments from everything else? We were able to come up with a tool that allows clinicians and staff to effectively separate instruments, high from low risk instruments within a set, and assess the efficiencies that come from the outcomes. One of the key things that separates this project from many others is the fact that we took it a step beyond it being a feel-good academic project. We were able to demonstrate the sheer impact that our innovations have led to, and as a result, our project was funded by the University Hospital, and as of last month, we actually were able to pilot our results, and as you can see here, by separating out the highest risk instrument, we now have managed to decrease reprocessing workload due to bioburden by 54%. You can, of course, now translate that into the financial numbers, as well as efficiencies in terms of quality, patient safety, and so on and so forth. And one thing that I'd like to note is that these numbers here are very conservative numbers, and so the impacts and overall benefits that we seek to see coming forward from this will only increase over time.